and suffering. According to Buddhist tradition, Buddha was born in Lumbini, which is now Nepal. Scholars are hesitant to make unqualified claims about the historical facts of Buddha's life. Most of them accept that Buddha lived, taught, and founded a monastic order during the Mahajanapada era. And now let's have a quick look on the Buddhist philosophy or the teaching of Lord Buddha. The main major teaching of him are as follows. The Four Noble Truths, also known as the Arya Satya in Buddhism, are: the world is full of sorrow. Desire is the root cause of all sorrows. Sorrows can be conquered by conquering our desire, and desire can be conquered by following the eightfold paths. And the eightfold paths are as follows: that is right understanding, right resolve, right speech, right action, right living, right effort, right thoughts, and right self-concentration. I think with this is a small introduction about Lord Buddha ji. And in the slide, we can see there is a famous quote: the mind is everything. What you think, you become. With this, I welcome our esteemed resource person of today's event, Professor H. Ramananda, sir. Already, sir has been introduced in the previous session. Just a small introduction about him. Professor Ramananda Singh, sir, is the head of the Department of Business Administration from Assam University, Silchar. And he has a vast experience in the field of general management, marketing management, and research methodology. That was a little introduction about sir. Sir, all over to you, sir Ramananda, sir, for the session. Sir, namaskar, sir.
Thank you, Partha. Thank you very much. So thank you, Partha. Since yesterday also I could not complete chi-square, today if time permits, let me take what was left out yesterday. So let's go straight to the correlation analysis. Dipjyoti, is it visible?
Visible, sir.
Correlation analysis.
Yes, sir. Visible.
Yeah. So let's go straight, because yesterday I could not find time to complete my chi-square, and within 2 hours completing, some important topics which we complete in 1 week or something, it's very much difficult. But nevertheless, let me try to complete. See, normally in research methodology, we come across two types of data: qualitative data and the quantitative data. Now, if we have a quantitative data, then we can do at least two things. One is compare the mean and establish the relationship. Let me remind once again, in research work, we come across two types of data. One is qualitative data and the quantitative data. And if the data is of quantitative in nature, then we can do at least two things. One is to compare the mean, the way we have compared yesterday means, and then establishing the relationship. Now, correlation analysis. Correlation analysis deals with association between two or more variables. Correlation analysis attempts to determine the degree of relationship within the variable. So with the help of correlation analysis, we try to find out the direction and the degree of relationship. Yesterday I have mentioned that two types of variables always we come across in the analysis of research. There is continuous variable and discontinuous variable. So continuous variables is also called criterion variable. It can be divided into, this variable can be divided into whole number as well as fraction. Achievement, anxiety, adaptability are the continuous variable. This continuous variable, it cannot be expressed, and it can be expressed only in whole number. These are discrete. So gender, residential background, rural, urban, caste, number are the discontinuous variable. So the problem that will come across in the correlation analysis is that First, determine the relationship. Check whether there is any relationship exists or not. If so, then test whether it is significant. And if it is significant, then establish the cause and effect relationship. So let me stress the point once again. The problem of analyzing relationship between variable should be discussed in 3 stages. First is that determine whether a relationship exists or not, and if exists, test for significance, and then try to establish the cause and effect relationship. You come across the positive and negative correlationship. If the data is arranged like this, X variable may be cost or sales revenue, Y may be cost, so X and Y variable. Now, if X increases and Y also increases, then it is called positive correlation. Then we call it correlation is positive. And if both the variable vary in opposite direction, X varies, X increases and Y decreases, then we call it negative correlation. So if X varies in the same direction, Y also varies, positive correlation. And if X varies in one direction and Y varies in the other direction, then we call it negative correlation. So simple correlation, partial correlation, multiple correlation that we have come across in correlation. When only 2 variables are studied, it is the problem of simple correlation. And when 3 or more variables are studied, this is a problem of either multiple or partial correlation. 3 or more. Now, in the multiple correlation, 3 or more variables are studied simultaneously. When we study correlation between yield of rice per acre of land and the amount of rainfall and amount of fertilizer used, it is a problem of multiple correlation. On the other hand, in partial correlation, we recognize more than 2 variables, but consider only 2 variables to influence each other. The effect of other variables, the effect of other variables, influencing variable being constant. Let me repeat once again. On the other hand, in partial correlation, we recognize more than 2 variables, but consider only 2 variables to influence each other. Other variable, we keep them as constant. So we'll be discussing today simple correlation, and then partial correlation, and then the multiple correlation. Now, why we are studying correlation? The significance is most of the variables show some kind of relationship. There is relationship between price and supply. There is relationship between income and expenditure. With the help of correlation analysis, we can measure in one figure the degree of relationship existing between the variable. Yesterday also I told you that one of the important objective of statistics is to find one single figure. So once we know that the 2 variables are closely related, we can estimate the value of one variable given the value of another. This is known with the help of regression analysis. So there is a close relationship between the correlation analysis and regression analysis. First, you establish and check whether there is any relationship or not. If relationship established, then you can find out the value of one variable with the help of the value of another unknown variable. You can find the value of unknown variable with the help of the value of another known variable with the help of regression equation. So once we know that 2 variables are closely related, we can estimate the value of one variable given the value of another. This is known with the help of regression analysis. In business, correlation analysis enables the executive to estimate cost, sales, price, and variables on the basis of some other series with which these cost, sale, price may be functionally related. So the effect of correlation is to reduce the range of understanding. The effect of correlation is to reduce the range of uncertainty. The prediction based on correlation analysis is likely to be more near to reality. Methods to study correlation say uh, these are graphical method, scatter diagram method, and graphical method. These two methods can help us in knowing only the direction, not the degree. The degree of relation can be done with the help of these two methods, comparisons and experimental correlation. With the help of diagrammatic method, you can say scatter diagram method. If the when you draw the graph, if all the lines, if all the points falls on a line like this, then it's called perfect positive correlation. And it is if it is like this, then it's called perfect negative correlation, and so on. So we'll focus today only on calculation part. And this also, if when you draw the diagram, it is like this, then it's called perfectly positive, perfectly positive correlation, and it is perfectly negative correlation. And if it is like this, then there is no correlation. If it is like this, then there is no correlation. When you plot the points on the graph paper, or when you draw the graph with the help of SPSS, if you got this type of thing, then we will say positive correlation, negative correlation, and then no correlation, no correlation. But I'll not be focusing on how to draw the graph and how to draw the conclusion. The comparison coefficient correlation. Comparison coefficient correlation, the formula is like this. Earlier we used to calculate manually. R is summation of xy divided by n into standard deviation x, standard deviation y, where small x is x minus x bar, capital Y is y minus y bar, and n is number pair observation. Standard deviation x, this is for the series x standard deviation, and this is for the series y standard deviation. And when you put all this, when you find the value of all this, and then when you substitute in this equation, then you can find the correlation R. The formula is only when the deviation is taken from the actual mean and not from the assumed mean. And when R is +1, perfect positive correlation. R is equal to 0, no correlation. R is equal to -1, perfect negative correlation. In practice, +1, 0, and -1 are rare. Suppose if this is a numerical, there are 5 students, their mark score in accountancy and their mark score in statistics are given. We assume that those who are good in statistics will also be good in accounting. So we would like to know, is there any relationship between a mark score in statistics and a mark score in accounting? Normally, we believe that those who are good in statistics may also be good in accounting. So you know the formula. So in the formula, we require summation xy. So accordingly, as per our requirement tabulation, we also require summation x squares and then summation y square. So as per the requirement, let's make a table. Accountancy, we resume as x, static y, then this small x, x minus mean, small y, y minus mean, then this is x square, and this is y square, and whatever we require in the formula. In the formula, we have calculated here on the table, and then we substitute this formula, these values in the equation. After substituting values in the equation, we get R is equal to 0.429. At the beginning, I have said that in the correlation analysis, check first whether there is any correlation or not. If exists, find it out and test whether it is significant or not. Now we have found out R equal to 0.429. From this 0.429, we can't draw any conclusion because Whether R is significant or not, we don't know. We have to test for significance. One way of testing a significance is probable error, like this. The probable error is given by 0.6745 and then into 1 minus R squared divided by root over n. So if R is less than probable error, R is not significant. So there is no evidence of correlation. If R is greater than 6 times the probable error, R is significant. Now we used to calculate manually like this. First we find out the R, then we calculate the probable error. Then if R is greater than if R is less than probable error, R is not significant. If R is greater than 6p, then R is significant. Now, if it is not significant, then whatever the value of R that we got is not important enough. Not important enough. It is not large enough, not big enough to draw the attention of the decision maker. So it is not so significant. But if it is significant, then we have to. It is significant, then this happened by chance plus the actual relationship. So this thing has to be taken into consideration by the decision maker. Now let's test it. So R was 0.429. Now probable error is 0.674 by into 1 minus R squared divided by root over n. Now probable error is 0.24. Now 6 times the probable error is 1.44, whereas R is 0.429. Since R is not greater than 6PE, R is not significant. So the relationship is there, but it is not strong enough to draw the conclusion. It is not large enough to draw the conclusion. Simple. The relationship is there, but in a moderate way. There is no need for drawing special attention from the decision maker because R is not large enough. Now, second one was Spearman's rank correlation coefficient. When the data are in ordinal scale, when the data are being given in terms of rank, then you have to use the Spearman rank correlation. So Spearman rank correlation is used when the quantitative measurement cannot be made, like efficiency, honesty, performance, which you can put in terms of ranking only. The quantitative data can also be used using Spearman rank correlation coefficient when you do the ranking. This formula is for ranks. Efficiency can be ranked, honesty of the people can be ranked, performance can be ranked. When you rank the data, then we can find the correlation R with the help of Spearman rank correlation coefficient. So Spearman rank correlation coefficient is R equal to 1 minus 6 summation D square n divided by n, then whole into n square minus 1. This is Spearman's rank correlation coefficient, where D is the difference in rank between the two variables, and n is the number of pair of observation. Let's see, the ranking of 10 students in 2 subjects in accounting and auditing are given below. Ranking. Mr. A ranked 3 in accounting and ranked 6 in auditing. And Mr. B gets 5 marks in accounting and 4 marks in auditing. So we wanted to know, is there any relationship in the mark score, in the ranking of the students in accounting and auditing? Normally we assume that, that if somebody is good in accounting, then somebody should also be good in auditing. So is there any relationship between the ranks in the accounting and the ranks given in auditing of the students? You can find it out by using the rank correlation coefficient. So Mr. A get rank 3 in accounting and 6 in auditing. So what is the difference in rank? 6 minus 3 is 3. So D square is 9. First, take a difference between the ranks and then take the square of the ranks, square of the difference in rank. Take the square of the difference in rank. Suppose Mr. B gets rank 5 in accounting and 4 in auditing. So difference is 1. So 1 square is D square is 1. So this is the summation of D square. Summation of D square is 214. So by substituting here, we got that the experimental correlation is 0.296. You have to take the absolute value, 0.2969. Now, after calculation, still we are yet to draw the conclusion whether it is significant or not. In SPSS, simply P with reference to P value, you can come to the conclusion that it is significant or not significant. But in the case of manual calculation, we have to refer to table value. We refer to table value. See here, number of pair of observation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. So for n is equal to 10, at 5%, what is the value? 0.6364. 0.6364. And if it is two tail test, then you have to take the value on the right side, or on the right side 0.6364, on the left side minus 0.6364. You have to do like this. 0.6346 on the right side minus 0.636. Then what was the value of R? The value of R is 0.29. So whether 0.29 lies somewhere this side below 0.63. So hypothesis accepted or not? See, if the value lies in this region, zone of acceptance, 0.29 is less than 0.63. So it lies in the zone of acceptance. So hypothesis accepted. So if you want to test hypothesis, then there is no relationship, there is no correlation in the rank data of the population. There is correlation in the rank data of the population. Alpha 5%, the table value is 0.6364 at alpha 5% level of significance, and for N10. Since R value 0.296 calculated value is less than 0.632, null hypothesis is accepted. There is no correlation in the rank data. There is no correlation. Whatever we find, 0.29 is not significant enough to draw the attention of the decision maker. So whatever happened was by chance only. This relationship is in a small way, they are having relationship, it is by chance, and the relationship is not significant. So correlation analysis, you can find one, that is comparison correlation manually, and another is for rank data comparison, experiments rank correlation. So for experiments rank correlation, there are three cases. One is when the ranks are given. First one is when the ranks are given. Experiment correlation coefficient can be when the ranks are being given, and when the ranks are not being given, where you have to do the ranking. And when another one is when the ranks are repeated. When the ranks are repeated, this formula has to be modified. When the ranks are repeated, then 1 minus 6 summation d square divided by n minus n square has to be modified into like this. And m is the number of pair where it has an equal rank. So in SPSS, it has taken care of automatically, but in manual calculation, we have to see whether the ranks are equal or not, and then when the ranks are given or not, and then there are three cases in the case of experimental rank correlation. Now I'll show you how correlation can be done with the help of SPSS. Now, yesterday I told you that first of all, you have to check whether your data is normally distributed or not. Even for correlation also, correlation analysis also, you have to first check whether the data is normally distributed or not. For checking the data normally distributed or not, it can be done with the help of three methods: descriptive statistics, significance of testing, and the graphical method. And descriptive statistics, when the sample size is less than 50, you can use only Shapiro Wilk test, Z skewness, and Z kurtosis. But if the sample size is between 50 to 300, then you can use Kolmogorov-Smirnov test for testing whether the data is normal or not. But if the sample size is large and greater than 300, then you can use skewness, kurtosis, histogram also can be used, box plot can be used to draw the conclusion whether your data is normally distributed or not. Now suppose a study on achievement in mathematics in relation to reasoning of class 12 students of government senior schools in Kasar district. I want to study in my research work whether the achievement in mathematics has something to do with the reasoning of the students of the class 12. So your objective is objective one can be the study of correlation between achievement in mathematics and reasoning of students. Another objective can be the study of maybe to study the correlation between achievement in mathematics and reasoning of male and female students. Another maybe you can put here two. Another maybe to study the correlation. To study the correlation, you can put like this also. To study the correlation between achievement in mathematics and reasoning of students belonging to rural and urban area. You can study the correlation between achievement in mathematics and reasoning of male and female students belonging to rural and urban areas separately. So from a very title, you can have number of objectives, and you can then from that objective you can find out whether there is any relationship or not. Suppose there is no significant from the objective you draw the hypothesis. There is no significant correlation between achievement in mathematics and reasoning of students. Suppose my hypothesis one is null hypothesis is there is no significant correlation between achievement in mathematics and reasoning of the reasoning of the students. So now we have here data of 20 students. Data here 20 students, achievement in mathematics and the reasoning level of the students. So we want to know is there any relationship between these two variables, achievement in mathematics and reasoning. Is there any relationship between these two variables or not? Go to analysis. We want to know, we have taken the data of 20 students, of class 11 students. These are their achievement in mathematics, and these are the reasoning level. So is there something to do with the reasoning level in the score on the score of the mathematics or not? You can check it. So correlate, you go to analyze, go to correlate, go to bivariate. These two variables we are here. Achievement is one variable, and then another is the reasoning. What is that? Correlation. Your variable in mathematics, okay. Reasoning variable, okay. So we want to know Pearson coefficient. So two-tailed test, okay. So you note down that the Pearson correlation here is 0.268. Point achievement and reasoning, here achievement in mathematics and reasoning it is minus 0.260. Minus 0.260, and here it is 0.268. 0.26. P value is 0.268, and R equal to minus 0.260. You note it down. My R minus 0.268 minus 0.260, and P value is 0.268. So the objective was to study the correlation. The objective was to study the correlation between achievement in mathematics and reasoning of students. Data was analyzed. Data was analyzed with the help of data. You can see the spelling is grammatical wrong. The data were analyzed with the help of product moment correlation. The result was given in the table number 1. Here, R is so for every table there should be table number correlation coefficient between achievement in mathematics and reasoning of students. So variable achievement in mathematics, reasoning are p value. So p value. So this p value is greater than 0.05. So R is not significant. Final interpretation is that the R minus 0.250 here is value bar, but p value is 0.268. It is greater than 0.05. So from table number 1, it can be seen that the correlation coefficient is minus 0.25, which is not significant. It indicates that there is no significant relation between achievement in mathematics and reasoning of students. Thus, the null hypothesis that there is no significant correlation between achievement in mathematics and reasoning of students is not rejected. Is not rejected. It may be said that the achievement in mathematics and reasoning of students are not significantly related. Now, see, you can find the commonness between the achievement and the reasoning. From the value of R, how far there is how much is the percentage of commonness between the achievement in mathematics and the reasoning? You can find it out with the help of R value. So the percentage of commonness between achievement in mathematics and reasoning of story equal to R squared into 100. R was 0.25 into 100. So 6.2. The commonness is only 6.2. The commonness percent is only 6.2. So this value of R, yours, 0.25, is not significant. It may be said that achievement in mathematics and reasoning of students are having low negative relationship. Low. Why? Because the commonness is only 6.2%. Commonness is on the more the commonness, the more will be the correlationship. Here, between these two variables, achievement in mathematics and reasoning, the commonness within these two variables is only 6.2%. That's why there is no significant relationship. In partial correlation. So the meaning of partial correlation is that, as I've given at the beginning, you will be having more than two variables. At a time, you'll be considering the correlations between two variables, and the effect of the other variable you'll consider is a constant. In partial correlation, the intervening variable can be held constant statistically. Now, variables can be achievement in mathematics, reasoning, study habit. The symbol will be R. See, if you're finding relations between this variable, second variable, third variable, the notation will be R2, 3 dot this first variable achievement in mathematics, you're parceling out. It means that the correlation between reasoning and the study habit by parceling out the effect of achievement in mathematics. In partial correlation, there may be 3 or more variables, but at a time you want to know the relationship between two variables while considering the effect of the other as constant. So can be held in partial correlation, the intervening variable can be held constant statistically. Here, this notation says that you will be finding the correlation between the reasoning and study habit by parceling out, by not considering the effect of achievement in mathematics. Again, if the variables you are having here 4 variables: achievement, reasoning, study habit, anxiety. Now, if R23 means the first notation is R23.14. So it means the correlation between the reasoning and study habit by parceling out the effect of achievement in mathematics anxiety. So we are not considering the effect of mathematics and anxiety. Yeah, we are considering the relationship of reasoning and study habits only, even though all the four variables are present at the time. We are considering the relationship between two variables only, while considering the other variable as constant. The effects are being considered as constant. So assumption of partial correlation are there must be minimum 3 continuous variables. Assumptions in partial correlation, and the correlation is to be computed between two variables by keeping the other variable statistically constant. In other words, the correlation is to be computed between two variables by parceling out the effect of the other variables. All the variables taken for partial correlation must be correlated with each other. There must be intercorrelation among themselves. All the variables must be normal distribution. There should not be any outlier. As I said at the beginning, before using your correlation analysis, before you go for partial correlation analysis or multiple correlation analysis, you have to check the data, whether your data is normally distributed or not. Yesterday we have checked whether data is normally distributed or not. I have given you three methods of checking normal distribution. With the help of that, you have to check normal distribution. Only then you can go further. After knowing that our data exhibits normal distribution, only then we are ready for going for application of the tools, the statistical tools for calculating correlation analysis. For example, now in partial correlation, to study our objective is to study the correlation between adjustment and anxiety by parceling out, means by not considering the effect of stress of teachers of private college of Assam. Now suppose we are conducting a research work. There we want to know the relationship between the adjustment level of the teachers and anxiety level of the teachers by not considering the effect of stress of teachers of private college of Assam. So the three variables are working at present. One is adjustment, another is anxiety, another is stress. So we want to know, the first objective wants to know the relationship between the adjustment and anxiety while we are not considering the effect of stress. So hypothesis one, see, for every objective you can have hypothesis. For every objective you can have hypothesis. For the first objective, my hypothesis is there is no significant correlation between adjustment and anxiety by parceling out the effect of stress of teachers of private college. So we have collected some data from private college. We have collected some data of teachers from the private college, the data on adjustment, data on anxiety, and data on stress, three variables. Now, without considering the effect of stress, we want to know the correlation between anxiety and adjustment. And this is partial correlation. So we have taken the data from 30 teachers of private college. Assume that we have taken 30 data from 30 teachers of private college or some. See, the first teacher, his adjustment score is this one. Second one is anxiety score and stress score here. And all these are continuous variable. All these are continuous, which can be expressed in whole number as well as in fraction. So adjustment score, anxiety score is for the second teacher. For the second teacher, his score in anxiety adjustment scale is 65, and his score in anxiety scale is 65, and his score in stress scale is 70. Now you have this one. Now we are ready to find out the partial correlation by keeping stress, by parceling out stress. We want to find a partial correlation. We want to find the partial correlation between adjustment and anxiety. While we don't want to consider the effect of stress. Now go to analyze. Go to analyze. Go to correlation. Go to partial correlation. Now here we want to find the relationship between adjustment and anxiety. Now as you bring here adjustment variable, you bring here anxiety variable, you bring here stress variable. Option. So we have to find, we want to know only the partial correlation. You can go, no problem, no problem. Is it visible? Did you see? Is it visible or audible? Dibo?
Visible, sir, visible.
Okay. So if my voice is also clearly audible.
Clear, sir.
Yes, sir.
Okay.
Yes, sir.
Yes,
So
clear.
now you go to OK. Now I want to find the correlationship between adjustment and anxiety by parceling out stress. So in the partial correlation, you can consider more than two variables, but at a time you'll be considering only two variables, where the effect of the other variable you keep constant. So here we don't want the effect of stress. So control variable has stress. So control variable is stress. So after controlling the effect of the stress, here we give the where we get the correlation value. Here for adjustment and anxiety is minus 0.83. Minus 0.83, and here p value is 0.001. P value is 0.268. Where is that? Control variable is stress, adjustment and anxiety. R value is minus 0.583, and p value is 0.001. So before drawing the conclusion, you have to bring those relevant figures on inside the table. So we have to make a table, then you have to bring those relevant figure. The objective is to study the correlation between adjustment anxiety by parceling out the effect. So the data were analyzed with the help of partial correlation, and results are given in the table below. Your first variable is adjustment, second variable is anxiety. So correlations between adjustment and anxiety were parceling out three. R1, 2, partial correlations between 1 and 2. After while parceling out 3, there is stress, and the p value is 0.001, and this is less than 0.05. So R value is significant. R value is significant. This negative correlation, R value is significant. Now first, then, so now you go for commonness. Commonness, we need two variables. Find the commonness. It can be seen from the table number 2 that the partial correlation coefficient is minus 0.83, which is significant at 0.001 level with degree of freedom 27. It indicates that there is a significant correlation between adjustment and anxiety by parceling out the effect of stress of teachers of private college. Now, thus the null hypothesis that there is no significant correlation between adjustment and anxiety by parceling out the effect of the stress of teachers of private college is rejected. So no relationship is rejected because the value is found to be significant. Now, commonness, the percentage of commonness is that R square in 200. So 34, moderately related. It may be said that adjustment and anxiety were found to have moderately negative relationship when the effect of stress is parceled out. The more the commonness, the more will be correlation. Here 34, out of 100, 34 means what? Moderately related. The more the commonness, the more will be the relationship. When we find the commonness between variable, we found 34 out of 100. So moderately negative relationship. Multiple correlation. Multiple, when you have more than, say, multiple correlation give us, combined contribution. But regression will give you individual contribution. So achievement in mathematics on the basis of reasoning, study habit, stress, anxiety, whatever. So this will come under multiple correlation. When you consider correlations more than two variables, multiple correlation. So multiple correlation helps in studying joint contribution. So the difference between regression analysis and multiple correlation is that multiple correlation helps in studying the joint contribution of all the variables. Joint contribution. say joint contribution of variable. But in the case of regression analysis will give us the individual contribution of all the variables. Assumption for multiple correlation. Assumption is there must be minimum of 3 continuous, more than 2. There must be minimum of 3 continuous variable. Why continuous variable again? Last time I've given you the continuous variable can be expressed in terms of can be expressed as a whole number as well as fraction. And the normal distribution is the distribution of continuous variable. So when you are considering the variable, continuous variable, then you have to check whether your data is normally distributed or not. Normal distribution is the distribution of continuous variable. That's why often we check normal distribution, check normal. Why normal distribution you are checking? Because the variable of our interest is continuous variable. And continuous variable follows normal distribution. So out of the 3 variables, 2 will be predictor and 1 is predicted variables. Predictor, dependent, independent, like that. All the variables must have high correlation to among themselves. All the variables must be normally distributed. All the variables must be normally distributed. So instead of considering other distribution, here we are talking normal distribution. A normal distribution is the distribution of continuous variable. So there should not be any extreme. I mean extreme. There should not be any extreme values, very small value or very large value. It should be within the normal distribution. Outliers should not be there. So joint contribution of A, B, C variable in predicting D variable. Now, if it is noted like this, RD bracket ABC, the meaning is that predicting variable is D. Predicting variable D, so this is the multiple correlation of D, where A, B, C are the variables. For example, if variables are 1, 2, 3, 4, R1 means total emotional intelligence. So multiple correlation are of total multiple intelligence, whereas the other variables are 2, 3, 4. Perception of emotion, managing on emotion, managing other emotion. Suppose you have 4 variables, and you want to find the multiple correlation. You want to find multiple correlation of 1, total emotional intelligence. Then you have the notation should be R1 along with other variable. Other variables should be within the bracket. So joint contribution of ABC variable in predicting D. Joint contribution of 2, 3, 4 in predicting 1 should be noted by like this. Let me repeat once again. Joint contribution of variable ABC in predicting D variable is denoted by like this, RD ABC. Likewise, joint contribution of total emotional intelligence of variables ABC of variables 1, 2, 3. Joint contribution of 1. Joint contribution of this perception, managing on total emotional intelligence will be denoted by like this: 1, 2, 3, 4. R1, 2, 3, 4. So this is the notation. Multiple correlation gives us the joint contribution. Regression gives us the individual contribution. Here we want to find the joint contribution of the variables. So this is the notation. Now, the title of your research work is like this: a study of total emotional intelligence in relation to perception of emotion, managing on emotion, managing other emotions of teachers of private college of Assam. We want to study total emotional intelligence of teachers. Total emotional intelligence of teachers in relation to how do they perceive about emotion, managing our emotion, managing other emotion of teachers of many other emotions of teachers of private college of Assam. So when you frame the title of your research work, you frame in such a way that there should be clarity. Your title tells you the population of study. Your title will tell you the direction of study. Your title will tell you the type of research work that you will be going ahead. So title should be clearly mentioned. Title will tell you the scope of your study. So here the scope of study is only private college of Assam, and the population of study is teachers of all private colleges of Assam. The title indicates the population of study. Title indicates the scope of your study. So a study of total emotional intelligence. So objective number one, to study the joint contribution of perception of emotion. Joint contribution of perception. Number one, perception of emotion, managing our emotion, managing other emotion in predicting the total emotional intelligence of teacher. What is the total emotional intelligence of teacher? In predicting what is the total emotional intelligence of teacher, you are using variables like perception emotion, managing our emotion, managing other emotion. So together you want to find the total emotional intelligence. For every objective I have said, you can frame hypothesis. So here the hypothesis is there is no significant joint contribution. Always null hypothesis, always no not. Always null hypothesis is expressed in terms of no not. So there is no significant joint contribution of perception of emotion, managing our emotion, managing other emotion in predicting the total emotion of teachers, in predicting total emotional intelligence of teachers. So there is no joint contribution. But later on you may find that there is joint contribution, but null hypothesis always say no not. So there is no significant joint contribution. So when you administer the questionnaire, you have several items for measuring the perception. In that perception score of teacher A, then you have some statements that you have collected in one strongly agree, somewhat agree, वगैरह वगैरह. So total score is 21 for managing on emotion. Then managing other emotion, again we have several statements, and the score on that several statement by this teacher, first teacher, is 42. Then total emotional intelligence also we have measured it, and this is 60. Now we want to know how much is the contribution of others variable on total emotion. You want to find it out. This is multiple correlation, but we have to go for regression. This multiple correlation. So let's go here, analysis, go to regression, go to linear. So here dependent was, we want to know total emotion. We want to know total emotion, whereas this perception is independent, managing our emotion is independent, and then managing other emotion is independent. So here multiple correlation is 0.551. Multiple correlation here is 0.551. For significance, you come here in the under regression here 0.022. So even though this one is multiple correlation, so we analyze it with the help of regression analysis. Here you get R multiple correlation value 0.551, whether it is significant or not. So the system has tested it with the value of here 0.022. 0.022 is given here. So please note it down here. R 0.551 and P value 0.022. So you bring that R is 0.551, P value is 0.022, 0.022 is less than 0.05. And here R4 means total emotional intelligence, total joint contribution of perception of emotion, managing our emotion, and managing other in predicting total emotion is given here now. So this is R. This correlation, multiple correlation R is 0.5, 0.5, 0.55, and it is significant. Now here, from the table number 3, it can be seen that multiple correlation coefficient is 0.551, which is significant at 0.0222. Now, it reflects that there was a significant joint contribution of a perception emotion, managing our emotion, and managing other in predicting total emotion and intelligence of teacher. Thus, there is no significant joint contribution. So, thus, there is no significant joint contribution of perception of emotion, managing our emotion, and managing other emotion in predicting total emotion. In predicting total emotional intelligence of teachers is rejected. Your null hypothesis is rejected, and alternative hypothesis there is significant joint contribution is accepted. Now, to find the joint contribution, you R squared into 100 and 30%. So moderately, we have a significant relation, but it can be said that total emotional intelligence can be predicted on the basis of perception of emotion, managing our emotion, and managing other emotion. And here, joint contribution is also 30%. Is it moderate? Moderate, still moderate. See, percentage of commonness help us. Percentage of commonness help us. Percentage of commonness help us in knowing that in indicating us, you know, percentage. This one percentage of joint contribution here. Percentage joint contribution help us in. No, this is the commonness. This is the commonness, and joint contribution is 30%. So you can say that there is a significant relationship, but significant is not so high. There is no significant joint contribution is rejected. So alternative hypothesis that there is significant contribution is accepted. And this is all about correlation. And before I finish this I start regression. Let me tell you one thing. I don't know much, whatever little thing I know, I would like to share with all of you the way I understand. But sometimes it is online and then you could not explain or you cannot ask the question also, is the problem. See, you'll find in correlation positive and negative. Well, if the two variables moves in the same direction, like x increase, y also increase, then it is called positive correlation. But here x increase, y decreases, this is called negative correlation. And then when you're talking about two variables only, then it is called simple correlation. When you're talking about the relation between more than two variables, then either we are talking about partial correlation or multiple correlation. At a time when you consider only two variables, other variables are being considered constant, then you are talking about the partial. But when you're talking about the joint contribution of all the variables at a time, when you're considering all the variables at a time, then this is called multiple correlation. And then why we are studying correlation is I've said that most of the variables show kind of relationship in our day-to-day life. There is a relationship between price and supply, income and expenditure. Once you know that there is a relationship between two or more variables, then with the help of regression analysis, you can predict the value of one variable, taking the other variable as independent variable. So once you know that there is a correlation, then you can establish the correlation equation also. Then you can also predict a particular variable on the basis of other variable that can be done with the help of regression analysis. I remember in when I was in class 12 or something, even up to the stage of BSc, they give equation, cos equation. The equation of the cos is 2 plus 5x, 5y, whatever, whatever. Then I thought, from where this equation comes? Then the equation of the profit is x squared plus 2x, whatever, whatever. From where this equation comes? We used to do differentiation, integration, but we wonder, but I wonder at the time, from where this equation comes. So this equation can be established when you know the relationship between the variable. So let's go to regression analysis.
So, can I ask you something?
You better ask. I would like to listen to the question after my things are being covered. Otherwise, yesterday also I could not cover your chi-square. You note it down and you put in the chat,
Okay,
or
sir.
after I cover something that I wanted to cover today, you can ask. Otherwise, my 30 minutes will go away while answering or discussing, and the remaining portion I would not be able to
Okay,
cover
sir.
it.
Okay,
See,
sir.
what one is that we also don't understand at the beginning. After attending such program, we noted down something. We asked ourselves some questions. At the beginning, so many questions were lurking in our mind. But after attending some program, one after program, in some program I got answer. In some program I did not got answer. Then after coming back, discuss with our colleagues. Then in this way, in the last so many years, some of the questions were being clear. Still, many questions are there lacking in our mind regarding the techniques that we are using. You can ask me. Let me cover some, because I have to complete everything before 6. Sorry, I'll give you the chance to ask. Divuji, Dr.
Yes, sir.
Nimister,
Sir,
this
sir.
is my
Visible.
regression.
Visible, sir.
Sorry, but this time I'm could not give the chance for you participant to ask me question, because let me complete this part.
No issue, sir.
Otherwise, I may be thinking that later on that I couldn't complete within the stipulated time. So let me try to complete. I'm also learning.
No issue, sir.
I'm also learning how to deliver. So regression analysis. So regression analysis is a statistical device with the help of which we are in the position to estimate the unknown value of one variable from the known value of other. So variable used to predict the variable of interest is called independent variable or explanatory variable. One independent, explanatory, another was explained variable or dependent variable. The thing that we want to know, the thing that we want to predict is called dependent or explained variable. And the variable on the right side of the equation will be your explanatory variable or independent variable. The difference between correlation and regression analysis: correlation coefficient is a measure of degree and direction. See, correlation analysis gives you the degree and the direction of relationship. But regression analysis study the natural relationship between the variable so that we may be able to predict the value of one on the basis of another. So regression helps us in predicting the value of one variable on the basis of another variable. But correlation analysis simply gives us the degree and the direction of relation. Here makes the difference. So in regression, one variable is taken as dependent and another as independent, thus making it possible to study the cause and effect relationship. So if you want to study the cause and effect in your research, then regression is the, after correlation, regression analysis has to be done. There may be regression equation, also known as estimating equation. You will have two regression equations. Why? See, suppose you are having two variables, y and x. You can have one first equation, y on x. Another equation is x on y. So you can have two regression equations. Regression equations are algebraic expressions of the regression lines. There are two types of regression equations. manually we used to calculate. Today I'll be telling you a little bit about how we calculate manual, but I'll be stressing on SPSS. The regression equation y on the y on x is independent. Y on x is y equal to a plus byx x. There it is regression equation of y variable on x yx. So regression coefficient of y on x is denoted by byx. But if it is regression equation of x on y, then it will be bxy. Now the first equation is regression equation of y on x. So your regression coefficient will be here suffix yx. Now this a and b can be solved by two normal equations. This one y equal to na plus byx, and this for these two equations a and b you can solve by using these two normal equations. And again y x on y for regression equation on x and y. So this is the regression coefficient of xy, and the AB can be solved with the help of these two normal equations. We have this normal. So after solving A and B, then you got the regression line. Here also, after solving from these two equations, the value of A and B, when you substitute here, you got the regression equation y on x. So two equations, depending upon which variable you are taking as dependent. Depending upon which variable you are taking as dependent and independent, you can have two regression equations. One is x on y, another is y on x. And here, if you know the regression coefficients, bxy, this one, and byx, if you know this, byx and then bxy, you can easily find correlation R with the help of this equation, root over byx into bxy. You can easily find the correlation R if you know the regression coefficients. Both the regression equations should have the same sign. The condition is that both the regression coefficients should have the same sign. Both the regression coefficient cannot be greater than 1. R should have the same sign as regression coefficient. These are the conditions, but you can easily find value of R. Regression analysis provide estimate of the value of dependent variable from the value of the independent variable. And again, with the help of regression coefficient, we can calculate the correlation coefficient. Now, regression analysis provide estimate the value of dependent variable from the value of independent variable. Suppose if you have a equation of profit on cost, then how much for getting how much profit, how much cost could be incurred, you can easily find out. For example, your regression equation is profit on cost, and you want to know for obtaining this much of the profit, 100 units of profit, how much should be the cost. So once you have the equation, you can easily find it out. So from the following data, see, this is simple. This x can be cost, y can be profit. This x variable can be cost, y can be profit. So from the following data, obtain the two regression equations. That is y on x, x on y. Now, if it is y on x, then at the given value of x, you can find the value of y. Now, if it is x on y, then at the given value of y, you can find the value of x. So two regression equations you can find it out. Now, how we find manually? So depending upon your requirement in the equation, you require summation x, you require summation y, summation xy, summation y square. Depending upon your requirement for solving the value of constants a and b, x, y, we put here in the table. X column, y column, xy column, summation x square. You want summation x square, so summation x square column. You want summation y square, so these are the different column. Then you substitute here. You have to substitute all the values here. After substituting, you get the value of AB. Now you got the value of AB. Now, for equation y on x, therefore, this is the regression equation of y on x. Now, when x is 12, y, how much is the y? The question, when this x is 12, how much will be the value of y? Y is this. Once you establish the regression equation, then you can predict for for value of the question asked was when x is 12, what will be the value of y? So when you put the value of x 12 here, how much will the value of y? Y is 119 minus this is ultimately you get when x is 12, ultimately you get the value of y. Similarly, you can determination regression equation of x on y. You have to find two regression equation. After finding this is the regression equation, therefore the regression equation of y on x is this one, and then for a given value of y, you can find the value of x. So let me repeat once again. If you consider two variables, you can have two regression equation: x on y, y on x, and then from that, for a given value of x, you can find the value of y, or for a given value of y, you can find the value of x. There was the benefit of using regression equation. Now, from this is you go to this question and you understand the importance of regression equation. The following table shows the cost and profit for 8 years of a company. This is the cost of the company 8 years. This is the profit of the company 8 years. We want to know whether there is any relationship between the cost and profit. Obtain the regression equation of y on x, means obtain the regression equation of profit on cost, and find the expected profit for a year when the cost is 49. Another is obtain the regression equation of x on y. X is cost. Obtain the regression equation of cost on profit, and obtain the cost when the profit is 60. So once you establish the regression equation, then you can easily find the value of one variable on the basis of another, on the given value of another variable. So regression analysis, when joint contribution of two or more variables in predicting a variable, multiple correlations shall be used. For studying individual contribution of two or more variables in predicting a variable, regression analysis can be used. So when you talk about the joint contribution, it is multiple correlation. When you talk about individual contribution of two or more variables, we're talking about regression analysis. So when I'm talking about multiple joint contribution, we are talking multiple correlation. When I'm talking about individual contribution, I'm talking about regression analysis. If one wants to establish regression equation for predicting a variable on the basis of two or more variables, regression analysis is used. So if one wants to establish regression equation for predicting, now not only trying to know the individual contribution, if you also want to know the establish the regression equation, then you have to go for regression analysis. Assumptions for regression analysis: there must be two or more variables each having measurement either on interval or ratio scale. That one of our respected professor has already taken this topic. Data can be measured on 4 scale: nominal scale, ordinal scale, interval scale, ratio scale. And data collected on interval and ratio scale are also called metric data. They are quantitative data. Data collected on your nominal and ordinal are non-metric data, qualitative data. So that if at all you want to use the regression analysis, then there must be two or more variables each having measurement either on interval or ratio scale. So it should be quantitative data. The distribution of its continuous variables shall be normal. So each of the variables should be continuous in nature, and the data should exhibit normal distribution. Therefore, data should follow normal distribution. All the variables must be related with each other. There should not be any outlier. Extreme items, too small, too large items should not be there. So that's what we have calculated. Just now we have calculated now this one. manually. I've shown you manually how we calculate the regression equation of x on y. When we can show it by numerical. We can show it by fast data stack is normal. We can use SPS. Fast let us use let's try to find out whether these x and y variables are normal or normally distributed or not. Before, is it visible? Dr.
Visible,
Divjyoti?
sir. Visible.
Now this data x variable, y variable. Now let us check its normalcy. Analysis, descriptive, go to explore. Then both the variable you want to know. Descriptive. We don't know histogram also. We want to know normality. We want to know normality only. Let's go. For x, Divjyoti, please note down this one. For x, skewness 0 divided by 0.913. For x, your skewness, that skewness will be 0.00 divided by 0.913, and kurtosis minus 1.200 divided by 200 by 2. For x variable, z skewness is 0 divided by 0.910. 0 divided by 0.910 will be 0. Then z kurtosis will be minus 1.2 divided by 2. This is for x variable. And now for y variable, 0 by 0.910. Again, kurtosis there will be point. We have to note down only that is relevant to you. We have to note down only relevant to you. Now, for x variable, your SRPO is 0.96, more than 0.05 normal. Then your y data is 1 greater than 0.05. So normal. So either you decide from this skewness kurtosis or you decide from the Shapiro. Both the variables are normal. Once you know that these both the variables are normal, then let us go for correlation. Is it visible? My slide.
Visible, sir.
So just now I told you to note it down. Just now I told you to know that skewness was 0 divided by 0.9130. Then z kurtosis was minus 1 divided by 0.06, and these both the values, these values 0 and minus 0.0 lies between plus minus 1.96. Last time I given you the table. Since it lies between plus minus 1.96, so the two both the data y and x distribute normal distribution. Shapiro also says that x is normally distributed. Shapiro also says that y is normally. Since they are normal distribution, now we are ready to go for correlation analysis. Now again, Is it visible? Pratim,
Sir, visible.
this XY visible? SPSS. My
Sir,
screen. Pratim,
yeah, visible, sir.
this XYZ. Nah.
Yeah.
Now, this is normal. This is so normal. Let us go for regression. Analyze regression, linear. So the two equation x on y on x, x on y is also there, y on x. So first let us take y as dependent and x as independent. R value is 9.19. R value is 0.9199. 0.919. You take the R value as significant value from here, 0.027. When it is x on y, R is 0.919. You take a p value from here, 0.27. Note it down. Is this new table visible? Partha? Partha?
Yes, sir. Yes, sir. Visible, sir.
No, for y
Yes,
on
sir.
x, for y on x, just now I told you to note it down 0.027. And 0.027 is greater than 0.05. So your R is significant. And what about your beta value? 0.65. 0.65. Oh, I'm sure. There, 0.65, the beta value is also available there. I'll show you. Oh, this one, 0.6 minus 0.65. Have you seen a minus 0.65?
Yes, sir. Minus 0.65.
This unstandardized coefficient, this unstandardized B, this will give you the beta coefficient. Normally, we have y is equal to a plus b, y is equal to a plus by. That b value is this one, beta, unstandardized minus 6.00, minus 6.0. This is the beta value. And this is significant, 0.027, minus 650, and it is here 0.027. So minus 0.65 and P below P027, it is significant or not? So whatever we calculated manually, you also get the same thing from the SPSS. But the thing is that you should know what value to be taken from the output. So this was y on x. Similarly, you can find out x on y. And when you compare it with what you have calculated manually, you get the same thing. This is all about regression coefficient of y on x. Regression coefficient of y on x. Now let's go for multiple regression in quick way. The multiple regression and how to establish the regression equation. This portion, regression analysis, is going to be very much important because how to establish regression equation, number one. Regression. It is from the multiple regression, how you will be establishing the multiple regression equations. Just give me 1 minute. Okay. My throat become dry, so I have to drink a glass of water. Pratim, Partha.
Yes, sir. Yes, sir.
Now, multiple regression analysis. Suppose if the title of your research work is like this, a study of total emotional intelligence. The thing that I've done in the correlation, I'll be showing here again in the regression. A study of total emotional intelligence in relation to perception of emotion, managing our emotion, managing other emotion of teachers of government college. And this is the objective, to study the individual contribution of perception of emotion, managing our emotion, managing other emotion in predicting total emotional intelligence of the teachers. So if this is objective one, then we can have hypothesis. We can have one hypothesis. Okay, first, let us go for analyzing the objective, to study the individual contribution first. First, to know the individual contribution. Is it visible? My data?
Yes, sir. It is. Yes, sir. It is visible, sir. Yes,
So,
sir. It is visible.
one is perception, managing our emotion, managing other emotion. Now, let us first think about the individual contribution. Individual. And how you calculate individual contribution, there is a formula. First, let us note down from the analysis, regression, linear. So your dependent is total. Dependent is total dependent. This is independent. This is independent. This is independent. We also want to know some of the strategies, descriptive and the partial also, which we want to know. Partha, this very important. This very important is beta unstandardized, and then beta this one beta unstandardized coefficient and standard. These two columns should be noted down. Beta standard. This column is beta standardized.
Yes, sir.
So I think we lost the connection with sir, right?
Yes, sir. I think sir has lost his network connection.
Let us wait for a few minutes.
This one is unstandardized.
Yes, sir.
Again, standardized. Then this one standardized column also standardized. Perceptual emotion standardized is 0.520.
Yes, sir. Noting.
And then
Noting down.
on emotion under the standardized coefficient is 0.545. And then managing other emotion under standardized is minus 0.236. We're noting down unstandardized. Unstandardized will come in the regression equation. And we're talking standard coefficient of beta. This will come under partial contribution. And then the zero order also, please. Zero order. In the zero order, under the perception of emotion, zero order is 0.527. Zero order under managing our emotion is 0.296. Zero order under managing other emotion is 0.231. Only that much. So after noting down that, we'll come to the we'll come to the slide one again. Slide.
Sir, noted it down, sir.
So okay. We're coming to that. So multiple correlation was 0.625, and P was. I'm coming back again. Where is the one? Output I've taken out. No problem. Now, that beta coefficient you have noted down now. Beta coefficient, that one,
Sir,
unstandardized.
Yeah,
Unstandardized.
unstandardized one noted, sir. Sir, 1 minute, sir.
0.5.
Sir, 1 minute.
Okay.
Yes, sir. Noted it down, sir.
You noted down that beta coefficient 0.520 was unstandardized. Unstandardized.
Yes, sir.
And then this one is also unstandardized. This one was unstandardized. Along with the T value, I haven't set to T value, you have to note it down T value. The zero value, you have noted zero order. 0.527, 0.296, 0.231, you have noted down.
Yes, sir. Noted it down.
Right. Now, why standardized and unstandardized? Let me tell you theoretical part. Why standardized and different? Now, percentage of contribution can be calculated from your beta coefficient standardized in zero order. Beta value, that standardized beta value into zero order into 100 will be the contribution of each variable. This one percentage of contribution, and this one percentage. This one will be unstandardized, then zero order into 100. Percentage of contribution of each variable, standardized. This one is standardized b value and zero order. Standardized b value and zero order into 100. So this one is standardized b value, standardized b value, standardized b value, and then this is the zero order that I told you to note the zero order. And this gives you the percentage of contribution of each variable to the total emotional intelligence of teachers. Perception of emotions, individual contribution to total emotional intelligence of teacher is 27.4%. And another managing our emotion is 16.13%. And this one is numerically is minus 0.5%. So please note down this formula. Beta regression coefficient in the beta regression coefficient unstandardized are used for establishing regression equation. Beta coefficient standardized are used for establishing individual contribution of the variable. Individual variable contribution will be beta coefficient standardized R order into 100. Now here, if we ever want to establish the regression equation, then why? I told you to note down constant 23.22 constant part.
Yes, sir. Noted.
I told you to note it down the constant. Then under the unstandardized against the C, it was 23.225. Am I right?
Yes, sir. Right, sir.
Then 0.565 was for managing our emotion, perception emotion. For perception
Right,
emotion, beta unstandardized was
0.565.
X1 is perception of emotion plus your, I told you to note down beta unstandardized managing our emotion was
0.675.
Then X2. Then and the other emotion minus 0.226. So this is the regression equation that you have established. So your total intelligence of the teacher will depend on 23.22 constant part plus beta standard unstandardized coefficient of X1 variable, beta unstandardized coefficient of X2 variable, and so on. So finally we got the regression equation. Now for a given value of perception of emotion, for a given value of managing our emotion, for a given value of managing other emotion, you can easily get total emotional intelligence. Now in the company, in the organization, if Y is the profit, X1 is the human resource value, and X2 is the production value, X3 is another variable. Suppose then you can easily calculate the profitability or cause, whatever the case may be in that organization. So this is very much useful. I recall when I was in degree, we used to make differentiation integration. The cost equation is given below. Find the total cost or minimum cost. Then profit equation is given below. You know, I was thinking from where this equation was derived. So the equation was derived after making such analysis that beta coefficient is this, beta 2 coefficient is this, beta 3 coefficient is this. So regression equation plays a very important role in establishing the equation. And this can be done with the help of SPSS. Now regarding individual contribution, perception, emotion, individual contribution is your beta value, that standardized one, then R0. And this is 27.4 is the out of 100. 27.4 is the contribution of perception emotion. Then managing our emotion also from the calculation that we have from the arbitrary value. So 16.3 out of 100 is the contribution and so on. So this minus comes, I don't know what, because we have taken arbitrary value, but nevertheless, its contribution is minus to the total. Its contribution, numerically, its contribution is minus to the total. So this, and its contribution is significant. Its contribution is not significant, and its contribution is also not significant. Only the contribution of perception of emotion is significant. From the 27. So 0.04 is less than 0.05. So significant. So 27.4 out of 100 is more significant than 16.13. So 16.13.42, this is greater than 0.05. So it is not significant. But this is the only variable which has significant impact on the total emotional intelligence of the teacher. So this is all about the regression. So regression equation plays a very important role in knowing the value of one dependent variable on the basis of another variable. Now, before I come to say goodbye, yesterday I have because of some other reason, I could not complete your chi-square. Let me take one small portion of chi-square. Partha, hello. Partha.
Yes, sir. Yes, sir. Sir.
Ah, the screen has gone down. Okay. Well, my screen is visible or not? This screen is visible.
Yes, yes, sir. Slide. Yes, sir. Slide is also visible.
Non-parametric statistics.
Yes, chi-square written, non-parametric statistically.
Okay, okay. But
So we can see chi-square test in the screen.
but my small screen has gone down. That's why I'm checking. Okay. So my dear friend, Dr. Vijiti has given me a few minutes. Yesterday, I was running in a haze and then I could not complete chi-square. And chi-square is non-parametric statistics and very much important. It is widely used. Many research scholars are using chi-square, and some of the research scholars are using it without knowing when to use it. If the cell value is below 5%, you can't use chi-square. And then if the total number of item or number of observation is less than 50%, you can use chi-square. Now, chi-square is one of the non-parametric statistical technique. So chi-square, under the chi-square also you are having three: chi-square, goodness of fit, chi-square contingency, and McNamara. I'll show you. So chi-square comes under non-parametric. So under non-parametric statistics, suppose non-parametric statistics, if it is nominal data, then you come nominal data, then you come decide. One sample, then is chi-square goodness of fit. Nominal data, two sample, and if the two samples are independent, then chi-square contingency. If the two samples are dependent, then McNamara. Now, if the data collected is ordinal data, then you have to use Smirnov details. But if the data are nominal collected on nominal scale, then you have chi-square, chi-square goodness of it, chi-square independent test, contingency, and then McNamara. So conditions for applying chi-square: data are nominal scale to test whether a significant difference exists within the observed number of responses and expected number of category. And this is the formula. I'll show you only one how we calculate numerically, manually. Now you go to this question. A bottler, you know, in the past history found that 10% of his sales of cold drink comes from 200 ml, 35% comes from 250 ml, 25% of its sale comes from 400 ml, 30% of the sales comes from 500 ml. Now he wants to launch a new cold drink and want to see whether this same pattern follows or not. Let me repeat once again. A bottler of a cold drink found that 10% of its sales come from 200 ml, 35% of its sales come from 250 ml, 25% from ml. So these are nominal. The 200 ml, 250 ml, 400 ml, just nominal, and data are collected on this nominal data. So you have to apply chi-square. Now, last question is: the bottler decided to conduct a test market to determine the purchasing pattern of the various bottle sizes of the new drink. He wants to know whether the same consumption pattern follows for his new cold drink or not. He wants to know whether the same consumption pattern as earlier follows or new pattern follows for his new cold drink. And market was tested. In a small market, out of the 15980 bottles, 1690 comes from 200 ml, and then this one 5683 comes from 250 ml, 3945 comes from 400 ml, and the 565 bottles sales come from 500 ml. So do this figure from the test market indicates a change in the consumption pattern for the new drink? So null hypothesis will be there is no change in the consumption pattern. Partha, is it audible? Parthaji?
Yes, sir. Yes, sir. It's
It is thundering outside, that's why. So the null hypothesis will be: is there any change? There has been no change in the conversion patterns or various bottle size. Alternative will be: there has been a change in the conversion pattern for the bottle size. The level of significance alpha is 5%. Chi-square test is taken because the data were nominal data. And then decision rule. Decision rule is that degree of freedom is your sample size was your number of category was 4. 4 minus 1, 3. This is degree of freedom. Number 200 bottles, 250 ml bottles, 300 bottles, then 500 bottles. It means you have only 4 category, 4 categorization of the bottles. So 4 minus 1 will be 3 degree of freedom. Now let us refer to the table with degree of freedom 3 and the alpha 5%. With this is the degree of freedom 3, alpha 5%, degree of freedom 3, alpha 5% means 0.05. Alpha 5% means 0.05. 3, 7.81. Do you see this one? Degree of freedom 3.
Yes, sir.
Then 0.05, 7.81.
Yes, sir. 7.81.
So decision rule is if the chi-square calculated is less than 7.81 table value, null hypothesis is accepted. If the chi-square calculated is greater than 7.81, null hypothesis is rejected and alternative hypothesis will be accepted. Now let's calculate. So here the expected number of bottles corresponding to the 6 are expected. Expected is based on the past. The past was 10% comes from this, 35% come from this, 25% is come from this, 35% from this. So on the basis of total sale of this, expected was this. Now you put the column now. Size of the bottles to this column, observed was this one, expected was this one, observed minus expected square, observed minus expected square. When you make the summation of this is observed minus expected whole square divided by expected. This is observed minus expected whole square divided by expected. So this column. So when you make the sum of this is the chi-square. The chi-square is summation of observed minus expected whole square divided by E expected. So this is chi-square. So your chi-square is 12.395. Now, since the calculated value of chi-square 12.39 is greater than 7.81 table value, implies that the null hypothesis is rejected and the alternative hypothesis is accepted. There has been a change in the consumption pattern for the various bottle sizes. There is sales of the new soft drink of the bottle size follow a different consumption pattern. So with the help of chi-square, see, these bottle sizes are nominal. This is just by name, just categorization. 200 ml, 250 ml, for it's just a categorization, and we call it nominal. And data collected on this category are called nominal data. These are just by name, data collected on these nominals categorization, nominal or categorized called nominal data. So for 2 independent samples, let me show you one thing. For 2 independent samples, Partha, is it audible?
Yes, sir. Perfectly audible, sir. Perfectly audible.
So please go through the questions, everybody. So there are 2 types of treatment, new treatment and the conventional treatment. From the data given below about the treatment of 250, see, these should be more than 50. So this 250, total patient is 250, suffering from diseases, state whether the new treatment is superior to the conventional treatment. Now, new treatment, 170 people are being treated. 170 people are treated with a new treatment. 140 are favorable, 30 are unfavorable. And then 80 people are being treated with the conventional. So 60 were favorable and 20 were unfavorable. This is called contingency table. And we have
Sir, your voice is.
two sample of patients. One sample was treated by new treatment. Another sample was treated by conventional way of treatment. So two samples, and these two samples, and then favorable, unfavorable. These are just a categorization. So these are nominal data. This here nominal data. Look at the cell. Cell value are greater than 5. Cell value greater than 5. So you can apply chi-square.
I think sir got disconnected. Sir.
Yeah, too much network issues.
Sir, you are on mute, sir.
Okay. Is it visible?
No, sir. Slide is not yet visible, sir.
Okay. Then. Frequent disruption of the signal. Is it visible now?
Yes, sir. It is visible now.
I was saying that these are nominal data and cell values are more than 5. Total is 250 more than 50. Now you can apply chi-square. And whatever we see here are observed data. And you have to find the expected. Now, the question says, what was the question? Whether the new treatment is superior to the conventional treatment. We say there is no significant difference. There is no significant difference between the new and the conventional treatment. There is significant difference between the new null hypothesis, no significant difference. And then alternative hypothesis, there is significant difference. Whereas see, nominal alpha value is normally for social science, 5%. But for physics people, chemistry people, they can go up to 0.5 because they go for zero defect. And then in social science, 5% error. Alpha is 5% error. Probability of committing type 1 error. There is the probability of rejecting a true hypothesis when it is true. The type 1 error is the probability. Type 1 error is that when you reject a true hypothesis. Alpha is the probability of type 1 error. That means the probability of rejecting a true hypothesis is 5%. So here alpha 5% has been taken as error. Now, in social science, you'll find that most of the testing were done in 5%. Some you'll find in 20% also, but 5% is acceptable. But for physics, chemistry, in science, they can go even lower. They can get 5%. They can go even lower, 0.5% or 0.0%, because they are looking for zero defect. But social science, we deal with the human being, and to err is human is also there is a problem saying. So we give the margin of 5%. So chi-square statistics. Now table value alpha 5%, and your here it is. Here your degree of freedom will be row -1 into column -1. That will be the degree of freedom. So degree of freedom will be number of rows 2, number of column 2, 2 minus 1 to 1. So for degree of freedom 1, and then 5%, 0.5. So 3.84. Table value is 3.84. Table value is, decision rule is, table is 3. If the chi-square calculated is less than 3.84, table value, null hypothesis is accepted. If the chi-square calculated is greater than 3.84, table value, null hypothesis is rejected. Now, how you calculate the expected of row 1, column 1? Expected of row 1, column 1 is like this. If you want to find the expected of these, then you have to multiply this one divided by this one. I'll show you here. The formula is, if you want row 1, column 1 expected, R1 total, column 1 total divided by grand total. R1 total, column 1 total divided by group total. So R1 total is 170. R1, row 1, total is 170. Column 1, total is 200. And total is 250. So R1 total, column 1 total divided by total 136. Expected for row 1, column 2. Expected value corresponding to this. Row 1, this is row 1. Then column 2. So R1, C2, R1E, R1, R1, this the expected is only E1, 2 by 250. So 50 into 170 divided by 3. So likewise, you have to calculate. You have to calculate expected of this, expected of this, expected of this, expected of this. You have to calculate. Partha, is it audible? Partha?
Yes, sir. Perfectly audible, sir.
So now for calculating the chi-square, observe column, expect column, observe minus expected square column, observe minus expected square by E. When you make a summation of this is the chi-square. So chi-square value is 1.8376. And your calculated value here is 1.8376. Table value was 3.84 less. So conclusion, statistical inference. So calculation is 1.6 less. Here calculated chi-square 1.83 less than table value. So null hypothesis accepted. There's no significant difference between the new and the conventional treatment. There is no significant difference between the new and significant. So that means that the two type of treatments are equally efficient. So this is how we calculate with the manual. Now, if you want to go for calculation UPSC by SPSS, there must be at least one discontinuous variable. Data must be nominal scale. The number of observations in each cell must be 5 or more. There should not be any cell without any data. Partha, okay? Is it okay, Partha?
Yes, sir. Yes, sir.
If we want to go for chi-square using SPSS, there must be at least one discontinuous variable. Discontinuous variable means variable which should be expressed in a whole number. It cannot be 7.5. It cannot be 3.5. It should be whole. It should be expressed as a whole number, discontinuous. I can say male half, female half. How many male? How many female? So we have to say some whole number. Here, the way here we have said like this one. You can say 140.5 patients are favorable. 30.5 patients are unfavorable. You can say favorable means favorable, unfavorable means unfavorable. So here this continues. You have to express whole number. Now next is, now suppose.
Sir, pardon me, like we have to finish it within a few minutes.
I'm finished now. Thank you. I'm finished. Just I'll show you something. Now, a study of reaction towards online teaching of teachers of Assam University. A study of reaction towards online teaching of teachers. How do the teachers react towards the online teaching? How do the teachers react to online teaching? So 40 says strongly agree, 30 says satisfy, strongly satisfy. It means online teaching is interesting. 40 say strongly agree, 30 say agree, 45 say undecided, 120 say disagree. So this type of data are these are continuous variable, 40, 30, 45. So these are whole number, right? So you can, for this you have to use chi-square. You have to use chi-square. Then again, there may be another case. A male, female. For out of these 40, 25 are male. Out of these 30, 10 are female. So whether the interest in teaching depends upon the gender or not. Whether the interest in online teaching depends upon the gender. The more the female, the more female likes online teaching, and few males like online teaching. It is so, or whether the teaching depends upon the gender. You can easily find out using the chi-square. And for using chi-square, let me tell you one thing, very easy. And first you see whether data is nominal or not. First, see whether your data is nominal or not, and then see. I'm not bringing the. If I bring the data, it will take another 20 minutes. You go through the analyze, then you go through the non-parametric. Sorry. You go through analyze, non-parametric, legacy, the chi-square. Here is chi-square. And then chi-square can be for independent samples, for dependent, there's so many things, but here you have a chi-square. You can put here your data, and then simple, by clicking, you'll get the result. But for knowing whether I should apply chi-square or not, t-testing or not, z-testing or not, you need to know the condition for which chi-square is being applied. And if I apply chi-square, what is the intention that I should be getting from the chi-square? I apply t-testing, and what is that I am trying to extract from t-testing? And under what condition t-testing should be applied? Now, you apply ANOVA test. What is the intention of mine using ANOVA? Why? And what are the conditions, if at all, are applying them? So every technique has a purpose, and whether you're getting that purpose or not. So right from the object, should all be linked together. If we want to analyze chi-square, then right from the beginning, it is not ultimately that you go for chi-square. It is not like that. You should think from the, then I can apply ANOVA or chi-square or t-test or z-test or whatever the case may be. We have to design, you have to think in advance. Then you have to think about how the questionnaire structure should be. Then how many items is needed. How the tools should be developed for measuring anxiety. How the tools should be developed for measuring stress. How the tools should be developed for measuring the adaptability of the teachers. And how the tools should be developed. How the tools should be developed for measuring the interest in online teaching. So if you develop the tool on your own, then you have to test its validity and reliability before applying. Thank you very much. So at the beginning, I told you that after attending such program again and again, some of the questions are being removed. Still, some of the questions are lurking in my mind about the research. So those who are beginner, it will take time for you to understand, and then again, in due course of time, you yourself will be able to answer many questions. Why alpha at 5%, alpha 20%? You yourself will be able to answer many questions on your own. But if you attend the class in such training program, topics are very vast, times are limited, and again, platform. If it is again interactive platform, then we don't get much time for covering also. Many times it so happens. But nevertheless, from every program, let us learn something. And we also learn from something from the active participation research scholar. Thank you very much.
Thank you, sir. Thank you.
Sorry for encroaching the time.
No issue, sir. Indeed, these courses are vast, sir. It cannot be covered in short span of time. And network issues are there, so we cannot avoid this one. Thank you, sir. Thank you for your
Thank you.
delivering. Partho, please quickly offer the vote of thanks.
Yes, sir. Sir, thank you, sir, for such an wonderful insights. We could learn a lot of more things. Just a quick vote of thanks. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this occasion. I, Parthobatim Shoikia, the session coordinator of session 11 of the 2-week faculty development program on research methodology and applied econometrics for social science, convey my deep regards and heartiest thanks to our honorable resource person, Professor H. Ramananda Singh, sir, for his outstanding deliberation on important area of research. My special thanks goes to Dr. Dipjyoti Chaudhary, sir, Joint Convener Dr. Shravanti Maiti ma'am, Dr. Taraknath Sahu, sir, for organizing such an informative program. An event of this dimension cannot happen overnight. The wheel starts rolling months in advance. We have been fortunate enough to be backed by the support of the Department of Business Administration, Assam University, Silchar, and the dignitaries of Vidyasagar University. I also extend my gratitude to all the back-end coordinators for their continuous help to conduct the program smoothly. I take the opportunity to thank all the participants without whom the program would not have been possible. At the end, I can only say, if time is money, then today you have spent million for us. Thank you all for making this event so successful. Thank you, sir. Namaskar, sir.
Thank you, Parth. Thank you.
May I take leave of the platform from this platform?
Yes, sir. Yeah, we'll be
Thank you.
another
Wish you all the
session
best.
for 5 minutes. Yeah.
Okay,
Thank you,
wish you
sir.
all the best. Good night. Good night. Good night.
Thank you. So participants, sorry for crossing the time. You just have a 5 minutes quick break, and our next resource person will be ready to join within few minutes.